Welcome to Chemical Process Engineers channel. In this video series of pumps, we will cover all pump related important topics. In this video, we will discuss about definition of pump, key applications of pump, types of pump and important parts of the pump. If we want to simplify how pumps work, we can say that pumps operate by creating a pressure difference that drives the liquid, and the definition of pump can be given as a pump is a mechanical device that transfers liquid or slurries from one location to another by imparting energy to the liquid. It creates a pressure differential to overcome the resistance and force the fluid to move, converting electrical or mechanical energy into hydraulic energy. Where do we use the pumps? Pumps are essential in countless applications, from supplying water to homes and irrigating fields to driving industrial processes like chemical processing and oil refining. Key applications of pump are fundamental to many aspects of daily life and industry, and below are the few examples of pump uses. Water management. In water management, pumps are essential for water supply systems including municipal water distribution, irrigation and wastewater treatment. In agriculture, pumps are used for livestock watering, crop irrigation and drainage. In oil and gas industries, pumps used in the oil refineries for transporting crude oil, refined product and water. In chemical and pharmaceutical industries, pumps handle corrosive and hazardous fluids and are used in processes requiring sanitation and hygiene. In HVAC systems, pumps circulate fluid in heating, ventilation and air conditioning systems. In food and beverage industry, pumps are used to transfer liquid, ensuring sanitation and hygiene. In power generation, pumps circulate cooling water and fluids in power plants. In mining, pumps are used for trailing reclamation, slurry transfer and mine dewatering. In fire hydrant systems, high pressure pumps enhance the firefighting capacity of buildings and plants. In dredging, heavy duty pumps are used in dredge systems to move large volumes of solid and liquids. As a sump pump, pumps are used to remove water from basement and other areas prone to flooding. In boiler water feed systems, multi-stage pumps are used to feed water into boiler at high pressure. Here types of pump are shown, and this classification is done according to their operating principles. Dynamic pumps use rotational components like impeller to increase the fluid's kinetic energy and then convert it into the pressure. Positive displacement pumps work by mechanically trapping and moving the discrete volume of fluid. A reciprocating pump is an example using the pistons or diaphragm to displace the fluid. There are three types of dynamic pumps: centrifugal, propeller and turbine. And there are two main types of the pump: rotary and reciprocating. In rotary types of the pump, there are five types, which are gear, lobe, screw, vane and rotary plunger. In reciprocating pumps, there are two types, which are piston and diaphragm. Pumps are also classified based on the type of flow. First one is radial flow pumps, second is axial flow pumps and third one is mixed flow pumps. Radial flow pumps move fluid 90 degree to the shaft. In radial flow pumps, fluid enters at pump's eye at the center and exits radially outwards perpendicular to the pump shaft. These pumps generate high pressure and are suited for applications with high pressure requirements, and they are often found in oil and gas industry. Axial flow pumps move fluid parallel to the shaft and they are similar to propeller. These pumps move large volumes of fluid with minimal pressure and they are suitable for applications where large quantities of water needed to be moved. In mixed flow pumps combine radial and axial actions for balance between flow rate and pressure, and in mixed flow pumps, fluid is discharged in a conical direction and they offer a balance, providing the significant flow rate while still increasing the pressure. They are used when combination of high flow and decent pressure is needed. Pumps are also classified based on the impeller types. First one is open impellers. Open impellers have vanes only attached to a hub with no disc, and they are excellent for handling liquids with large solids such as wastewater or slurries because the open design provides large passageways. Semi-open type impellers have vanes attached to a hub with disc on one side. They offer better mechanical strength than open impellers and can handle small amounts of suspended solids. Closed impellers have vanes enclosed by the both front and back disc. This design is highly efficient for clean liquids such as water, as it directs all the fluid through the channels between the vanes. Here we can see different parts of the pump. One image shows side view of pump in which how parts connected with each other, and second image shows sectional view of centrifugal pump in which you can easily see internal parts and their arrangement. The primary part of the centrifugal pump are the impeller, which is a vaned rotor inside the volute casing, and shaft which connects the impeller and motor. These components are supported by bearings to maintain the alignment and reduce the friction, and sealed with a mechanical seal or packing to prevent the fluid leakage from the shaft. The entire rotating assembly is driven by a motor or other driver which supplies the mechanical power to the shaft. Here typical example of centrifugal pump is given. Based on the type of pump, these parts can be changed. On the left side you can see list of the important parts and functions of each part of the pump can be described as: impeller is the rotating part with vanes or blades that increases the fluid's velocity and kinetic energy by transferring rotational energy to it. Casing is the stationary shell surrounding the impeller. It guides the flow and converting the kinetic energy into pressure energy. Shaft is the central component that connects the driver like a motor to the impeller and transmitting torque and enabling the impeller to rotate. Bearings are the support to the shaft and maintains its proper alignment with the casing. Sealing can be a mechanical seal or packing. It is located where the shaft enters the casing, and seals prevent the pump fluid from leaking out of the pump and protect the motor from the fluid. Driver is an external source, often an electric motor, that provides the mechanical power to spin the shaft. Suction and discharge nozzles are the entry and exit points on the casing through which the fluid is drawn into the pump and then discharged to the system. Hope you have found this video more informative. To learn more about the pumps, see the other videos uploaded in the pump series. Thank you.